Hello, this is Paul from Foresight Tech. In this video, let's prove Theorem 1.4.7, which is the properties of a negative exponent of a square matrix. Okay. We defined an exponent for a square matrix, right? And we also defined a negative exponent. So here we have some property. The definition of a negative exponent is just the exponent, the power. Okay, we simply say the power of the inverse. Okay, and then you see if A is an invertible matrix, of course square. Okay, and the n is a non-negative integer. Okay, so and the first result, okay, we say the inverse of A is also invertible, and if the inverse of A is invertible of invertible, back to the original. They're quite obvious, right? So, but you have to prove. It's similar as this is the power exponent, okay, like the power rule. Okay, so similar like the power rule. The negative one's power is the inverse. Okay, this is like a power rule. The second is also. Okay, so let me. So like a power rule, okay, of exponent. We learned a long time ago. And then the second, let's see. A raised to the nth power, okay, which is n8 times together. It's also invertible. Okay? And the inverse is like a power. See, the power of n, the power of power. This is like a power of power, like power rule again. So we can switch the order. So therefore, the inverse is this number. We have to verify this times a raised to the nth power equals identity. So the same for both. So here and here is the same. The last. See, k times the scalar multiplication is also invertible. That is quite sure, right? If k is not zero, if k is not zero, it should be invertible. So what is the inverse? And it says the inverse is this one. It's similar like you can distribute. Okay, you can. So here is like a product. K is a number. K is a number. So that the power is -1 power of product. So you distribute this power to k, distribute this power to a. So therefore, this is like a how do you say, like a power of a product. Okay. Power of a product of exponent we learned before. See, so very good properties for the negative exponent of matrix, because all the property keep it the same as the number that we learned before. Now let's prove, is that true? So if A is invertible, the inverse is invertible. All we need is just to verify. See, if this is the inverse, so this times the inverse of A should back to the identity, right? That's the definition. We verify A times, or let's say inverse of A times A equals, is this equals I? Definitely, okay, definitely by the definition, right? So this matrix, right, should be the inverse of inverse of A, okay? Because this matrix is times the inverse of A back to the identity. So that's good. That's true. A is true, and B. If A is invertible, A raised to any power, positive number is invertible. A times A times A. We learned the property before. Okay, the product of invertible is invertible, so A raised to the nth power is invertible. That's good. The power of invertible is invertible, so this is invertible. And then we verify what is the inverse, okay, of this. And finally, the inverse of like a power rule, which is a raised to the nth power. Okay, a raised to the nth power is a negative exponent. The definition is inverse of a raised to the nth power. We have to verify. So also verify like a raised to the nth power times inverse of a let me put another raised to the nth power. Change to a bracket. We have to verify this equals I. Okay, is this equals I? It's definitely y. Just write. Okay, just break down the exponent. See, a times a times a. Okay, and this is n a's times together. Imagine n a's. And then the second is inverse of a times the inverse of a times the inverse of a. And also how many? Also n. Okay, so now this is the definition. And this should be equals 0 because equals I, sorry. This should be equals I. Because we can associate. I skip or you use the associative property. Associative property. You can associate these two. What do you get? You get I, right? And then you cancel this. And then you associate the closest A and the inverse of A. And then one by one, you associate n times. So finally you get I. Yeah, that's good. If you get I, so what do we get? We verified. And this matrix is the inverse of this, right? So good. So B is 2. And then look at the C. K times A is invertible. If I find the inverse, of course it's invertible, right? So let's see Y. K times A. Oh, we just verify. So that's highlight. The inverse of this matrix we need to find is this. So we still verify. They multiply together back to identity. Is that true? It is. So K times A. This is a matrix. Inverse of 1, which is 1 out of K. K is not a 0. Okay. And then times the inverse of A. Okay. So here, so first, we have a property of okay. So both of homogeneous property. Okay. Or this we take out. So we have K times the inverse of K. Put out. And then we have A times inverse of 1. Okay. So the first is just a homogeneous property we learned before. And then this is 1 times identity matrix. It is identity. Okay, so therefore this matrix should be the inverse of the first matrix K times A. Yeah, that's the proof for the property. Thank you.